So with the last 10 minutes, I'll just talk about general arrangements and design drivers. So this slide is a little low resolution, so let's look at this higher. It's not that much higher, but here is a system diagram of the NEAR spacecraft communication system. NEAR is one of NASA's first discovery missions, the first mission ever to go to an orbit around an asteroid. So let's take a tour of the NEAR spacecraft's communication system. Here you have the geometric configuration of the NEAR spacecraft, where there's this low gain antenna on the aft side. There's a forward low gain antenna. And then we've got a high gain antenna and a fan beam antenna. All of these antennas are subject to the space environment. They need to have some line of sight to the ground station that they're communicating with. I'm going to say that the red antennas are for receiving. They have this gain pattern that is very wide, so it's able to receive at many angles, whereas the antennas that are transmitting to ground, so since it's in deep space, it needs to point at the Earth, which is, just a tiny little marble in your field of view. So you want to use this high gain antenna to precisely point towards the Earth, but you get much better gain profile or a higher intensity of signal if you have this directionality associated with it. Okay, let's look at this system diagram next. So here is the high gain antenna. This side is pretty much exposed to the space environment, but the high gain antenna is connected to this circuit diagram where there are a bunch of switches. The switches are connected to diplexers, power converter units, and amplifiers that are connected to receivers and exciters. So this is these are the antenna hardware. This is the electronic circuitry that supports the antennas and converts electromagnetic waves into these signals that computers can process. So here we have the more data processing circuitry. If you look at, it's not very clear, but if you look at the power breakdown of the different components, the transponder, which is the transmit receive, has a nominal power of 9.1 watts. The command detector unit has 1 watt. The telemetry conditioning unit, 3 watts. The SSPA, which is the solid state power amplifier, now this is known to be very power hungry, is at 34 watts. So that'll give you just a sense of the power hungriness of the different components in the communication subsystem. And then for weight, the X-band transponder is 4 kilograms. The conditioning unit is 0.4 kilograms. Telemetry conditioning unit 0.8 kilograms. Amplifier 0.8 kilograms. All right, let's go to the next slide. A typical arrangement for ground segments. So I got a question about the cost of your ground station setup. So I thought it'd be just a good opportunity to talk about the different kinds of ground segments you can have. So here's a Satnox ground station example. And from their website, they say that you can have access for a Satnox project. If you have access to a 3D printer, then you can put together your own ground station for between $300 and $400. Now, ground stations, as they grow in size, they do not grow linearly with cost. So bigger sizes will get substantially more pricey as you go up. If you look at our Kauai Community College ground station, there are two different settings. There's a UHF VHF and then the L and S band. The UHF VHF parts are about $30,000 in parts. And then the S band is more than $40,000 alone. And then if we look at the deep space network, so I just took this off of some space stack exchange, but they sourced it from NASA's Mission Operations and Communication Services. Just 4 2-hour-long contacts per week on the deep space network 70-meter antennas cost $3.43 million a year, or about close to $4 million in 2017 dollars. So you can see this, I don't want to say it's exactly some exponential trend, but it's definitely not linear. It's crazy how expensive things can get the larger you scale your ground stations. Okay, so is Artemis going to use the Satnox ground station network? Probably. That's up to you all, but I think that is the intention. Because we are kind of like a crowdsource open access CubeSat kit, I think it makes sense to contact in a crowdsourced open access ground station network. And this is indeed what Neutron One is currently using. And we've been pretty successful in engaging with the community and getting data packets from Satnox operators.